Hello everyone and welcome back to Exam Prep Solutions. Today we have another FE exam sample problem. This is going to be a dynamics one. We're going to be going over kinetic energy and the energy equation when it comes to the velocity of this ball here that we're going to be looking at. So I have the FE exam excerpt on the right going over kinetic energy and potential energy. We're going to be using these as well as rotational energy. So the problem states find the velocity of the ball at point B. So we're going to label this point 2 here. At point B, given the following characteristics, a mass of 4 kilograms, rotational moment of inertia of 2 meters to the fourth, and a W of 5. So given that, we're going to mark point 1 and point 2. That's the first thing you're going to want to do with this problem. Where does the ball start? Where does it end up? And that helps us define what we're going to use in terms of equations. So we have kinetic energy and potential energy. So with the ball at point 1, now I'm going to go back to my text tool here, so I can type out once again. So at point 1, what kind of energy do we have? So you want to pick your point, find out what kind of energies apply, and then equate that to the next point and what kind of energy applies there. So at point 1, we have mgh, right? Mass times gravity times the height, right? That's what's going to be at point 1. The ball's not moving yet, it's at rest, so nothing else applies. Now at point 2, we're going to have a variety of things. We're not going to have mgh anymore because the height would be effectively 0 if we're picking the bottom of that ramp as our datum. So we are going to have 1/2 mass velocity squared would apply since the ball is moving. Also rotational energy, and that's going to equal 1/2 I times the rotational velocity, W squared. So those are the three things that are involved. We set those equations equal to each other. mgh equals that first part there, 1/2 m v squared plus 1/2 the rotational moment of inertia, W, v squared, the rotational velocity. Okay, so that's our setup for the equation. We want to find the velocity of the ball at point B. We have the mass, that's 4 kilograms. We know what gravity is, 9.81, so you can see how this process works out. You pick your two spots, you find the equations that apply, and then enter in your variables, and you should be able to find the answer. 10 meters is the height. Then we have 1/2. I'm going to write 0.5. For my purposes here, the mass again is 4. We don't know the velocity, so that's v squared. We do know these other values here. 0.5 times I, which is 2, times the rotational velocity, 5 squared. So let's finally solve this problem here. So let's go 5 times 9.81 times 10. That equals 392.4. Then we have 2 times 0.5 times 5 squared, or 25 times, or 5 times 5. That equals 25 there. So we're going to have 392.4 minus 25, 367.4 equals this whole problem. Let me erase this point 1 here so that we can see what we're doing. Okay, so we have 367.4 equals now the 1/2 mass times velocity squared. Okay, like I said, we know the mass is 4, so 4 divided by 2 is going to be 2, so we're going to have 367.4 divided by 2 equals 183.7 equals finally v squared. It's 183.7 raised to the 0.5. And we get a final answer of 13.55 or 13.6. So I'm going to put B for our answer in this case. Okay, so that was a lot. What did we do there? Well, like I said, point 1 and point 2 for your problem. Find out which equations apply. In this case, the ball was static, so we just had mgh. Then once it got to the bottom, it was both rotating and moving, but didn't have that potential energy anymore. We set those equations equal to each other to find whatever we were looking for and inserted our variables. So that's how to apply the energy equation. Let me know if you have any questions on that specific problem. We have a free guide, the 5 steps to solving any FE exam problem. You can find that guide 100% free in the description box down below. Anyways, if you have any questions, leave a comment, and we'll see you guys in the next video.